Bismillahirrahmanirrahim. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Here, as I told you, that manometer is the instrument which is used to measure the unknown pressure of the gas. There is some other uses of the manometer also. Now, here I'm going to tell you that if you are going to find out the pressure of a gas whose pressure is required to be found, then what we have to do, we have to introduce that gas pressure to one end of the manometer, and this difference of height will tell you the uh, pressure of that gas. Now, if the situation is like this, now here you can see that if the situation is something like this, when you are applying the gas here on the one end of the manometer, okay, and this gas pressure, say the gas pressure which we are going to find out, it is Pg. I am representing this unknown pressure of the gas Pg, and Pg is greater than P naught. As I told you that P naught I am taking as atmospheric pressure. If this pressure is greater than the atmospheric pressure, then obviously this end will be in the lower level and this end of the manometer will be in the upper level. Okay, now you will have to see this difference of the level. Suppose it is 15 centimeter. Now, for example, this height is 15 centimeter. The question may be asked in such a way: if the examiner is asking, find the pressure of the gas above the atmospheric pressure, you will have to follow this question that he's asking, that what is the pressure of the gas above the atmospheric pressure. It means if he is asking the pressure above the atmospheric pressure, then only this height will be considered, which is 15 centimeter. So height of the difference of the column is 15 centimeter. So you can say that this pressure above the atmospheric pressure is 150 millimeter of Hg above the atmospheric pressure. So in terms of millimeter of Hg, like you tell the atmospheric pressure in terms of millimeter of Hg in the case of barometer, like I told you that when you are finding out the atmospheric pressure at sea level, it is 760 millimeter of Hg at sea level. In the same way, you can also tell that this pressure of the gas above the atmospheric pressure is 150 millimeter of Hg. And if you are going to convert this pressure in millimeter of Hg to Pascal, then you will have to apply this formula, that pressure of the liquid is equal to rho gh. Rho is the density of the liquid which is used in the manometer. Now you know that this in this manometer I am using Hg, mercury. So the density of mercury is 13,600 almost. So I am taking this value for the density of mercury. So if you are going to find out the pressure above the atmospheric pressure, then 13,600 multiplied by the value of G. Value of G, I am taking 10. You can also take 9.8. For the sake of convenience, I am taking this 10. H, the height of the mercury column, which was 15 centimeter. So here it must be converted to meters, because 15 centimeter is equal to 0.15 meters. So after converting this height into meters, we have to multiply all these three quantities. So you will get that the atmospheric, the pressure above the gas is 20,400 pascals. Okay. So this is in the case if I am going to find out the pressure above the atmospheric pressure. Now, if you are going to find out the pressure of the gas, what is the pressure of the gas? Generally, he is just asking you that what is the pressure of the gas? Then obviously, if he is not asking this question, what is the pressure above the atmospheric pressure, and he is generally asking that what is the pressure of the gas, then height of the mercury column will be taken as the total height of the column, because you know that the height of the mercury column in one atmospheric pressure is taken 0.76 meter, 0.76 plus this height. I'm doing this calculations in meters. Please observe it carefully, that here I am taking the height in meters. This is the height of the mercury column for one atmospheric pressure. Okay, at sea level, this is 0.76 meter plus this is the height of the difference of these two columns, which is 15 centimeter. I converted this 15 into meters. So both the units are meter. Adding these to 0.91. Now the total height of the mercury column for this pressure of the gas will be 0.91 meter or 910 millimeter of Hg. If you are asking in terms of millimeter of Hg, then this pressure will be 910 millimeter of Hg. If you are going to change this pressure into pascals, then again you will have to apply the formula rho gh. At the density of mercury is 13,600 multiplied by 10 multiplied by 0.91. So this will be the pressure, in this much pressure in pascal will be for this gas. Okay. Observe this situation. If this unknown pressure is less than the atmospheric pressure, like this Pg, if pressure of this gas is less than P naught, less than the atmospheric pressure, then what you have to do? Obviously, you know that the for the height for atmospheric pressure is 760 millimeter of Hg. So we can write down 76 centimeter of Hg. Okay. So if this pressure, unknown pressure, is less than the atmospheric pressure, then you will have to see this difference, which is lesser than the atmospheric pressure. So initially, you can just subtract 76 minus 15, which is 61 centimeter. Now 61 centimeter can be converted to millimeter of Hg like this. If you are, if he is asking that give the answer in millimeter of Hg, then this pressure will be 610 millimeter of Hg in terms of height of the liquid column. This will be the answer. But he is asking the answer in terms of Pascal. Then what you have to do? You have to apply this formula, rho gh, density of the liquid, Hg, multiply 10 and 0.61. This after subtracting this, because 76 centimeter is the 1 atmospheric pressure. From 1 atmospheric pressure, I'm subtracting this 15 centimeter. So this is 61 centimeter, and 61 centimeter, you know that it is 0.61 meter. So here I have to apply the value in meters. After calculating, I'm getting this 82,960 Pascal. This is the pressure of the liquid below the atmospheric pressure. Okay. Now another way of solving the same problem. Look at this carefully. Here I am using the atmospheric pressure. I'm using the height of the liquid column. Here the calculations are being done by using the height of the liquid column directly. Okay. But now I am not using directly the height of the liquid column. First of all, in the first case, I am finding out the atmospheric pressure using 760 millimeter of Hg. So P naught is equal to rho into the value of G into the height of the mercury column, 0.76. So I am calculating this first of all. So here you can see 13600 multiplied by 10 and multiplied by 0.76. So this will be the atmospheric pressure, 103360 Pascal. This is the atmospheric pressure. If you are using the formula like this, now look at this. As I told you that in the case when the height of the mercury column was like this, there was a difference of 15 centimeter like this. As I told you that when the Pg gas of the pressure of the gas, this height is 15 centimeter. Now pressure of the gas is equal to P naught plus rho gh. P naught, what is P naught here? Here P naught is this. P naught is 103360 plus rho 13600 and the value of G 10 and the height. Now height, what height you are going to use? This 15 centimeter. This 15 centimeter, 0.15 meter. Now 103360 plus this much plus 13600 multiply 0.15. So again, you can observe that what we are getting after doing the calculations, 12376, this one 123,760 pascals. You can observe that here I am already I'm calculating the atmospheric pressure separately. Here I am calculating atmospheric pressure separately by using 760 millimeter of Hg like this, and then I am substituting this value here, and for this 15 centimeter I am again calculating, I am again applying rho g h formula. So in this way, I have to do a lot of work to find out the pressure. Now you can see that 136,000 multiply 0.15 gives you 20400. By adding this, you will get this. Okay. So here you can see what is the difference here. Look here the difference. Look here the difference. Here I am using the value of atmospheric pressure directly. But here in this case, what I am doing, I am adding both the liquid column. The height of the liquid column for mercury is 0.76. I am adding this 0.76 with this height which is required. By adding this, I am doing this calculation rho gh in a single go. This is the only difference which is created here. If I'm using this case, in this case, as you know, that the atmospheric pressure P naught I calculated this much. P naught is equal to 103360 Pascal. And if this unknown pressure is less than the atmospheric pressure, then what you are going to do? Pg is equal to P naught minus rho gh. Now you can see that you have to do calculations like this: 103360 minus rho 13600, and the value of g, which is 10, and the height, which is 0.15. Now again, you are going to do the calculations 103360 minus 20400. By subtracting this, obviously you will get 82960 pascals. So these are the both ways to solving this.